Hello students, good morning. Today we will be discussing the continuation of our lesson yesterday, which is about classes and data types. So we will be having a little recap of what we have discussed yesterday. So yesterday we have discussed the various data types that the Java programming language is using, which is on this list. So among this list, there are byte, short, int, long, so on and so forth, in which each data type tries to fulfill a specific purpose. So primitive data types are in itself the basic data types that you are going to use when dealing with data or information in programming. So you can find this kind of data types also common in other languages. But it is not only these data types that are currently being in use, right? There are several data types that are commonly used, but they cannot be considered as primitive data types. Um, Rather, they can be considered as objects. For example, the data type string. String is an object because it uses the class char or the object, or rather the data type character. So string is an array of character, in which I will be discussing about arrays today as we left off with the topic. So before we dive in right through our discontinued topic yesterday, I will be showing you um, what the principles of object-oriented programming is. Again, there are three such discussed yesterday. It is abstraction, inheritance, and polymorphism. Abstraction shows you the relevant data, while the programming hides to you the internal processes of how the program works. That is what we call abstraction. Inheritance. Inheritance is the mechanism in which an object can acquire some, if not all, of the properties of another project. So in that example, if you look here in this picture, this is what we call uh, a hero class, in which we created yesterday. This is a class that we created a clockwork object from it. Now, if we are going to modify some of the properties and make use of it in a specific way, for example here, it doesn't actually strike that much different from what we have discussed yesterday. So, for example, we have made a monster class. It has various data types such as string, integers, and doubles, as well as Boolean data types. It also has methods which include interact, attack, stop, patrol, and move. Now, if we go on here in the two created objects, you will notice that there are some methods and data types that are not included from the original monster class. For example, you will notice there is three new methods. There's a skill 1, skill 2, and jungle spawn. So, going here to lane creep, there is also a new there are new methods as well as data types. For example, there is an integer called creep level. There's also stat growth function as well as lane spawn. We call this kind of modification of the original class inheritance. Meaning, you are taking some of the properties of the original object but modifying it to a specific way that you are going to use it. Now, let's move on to our discussion from yesterday. We will move on to arrays. So an array is a composite variable holding a fixed amount of values of a specific type. It could be int, it could be long, it could be a character, float, double, and so on. When an array is declared, the data type it will contain is set. When it is initialized, the number of elements must be set as well. An array has a fixed number of elements that can be accessed by an index, which points to the nth element of the array. It is important to note that the first element of the array has an index of 0. To begin working with arrays, consider the following statement. We will be making use of an array called character, which is commonly used as a data type. We will be using that for our calculator. So, for now, there is an example called float weight array. This defines a variable called weight array, which an array of floating point numbers. Note that the square brackets which denote that the variable is an array. So, as an example, I'm going to demonstrate how an array is being used. So, here he declares float array. Weight array. Then, the array can be initialized using the operator as follows. So, this as it is declaration. There are two steps in creating a variable in programming. First is the declaration, meaning you are giving something a name. Then, the initialization, in which we are trying to initialize it and give it a default value. So, for here, this is the declaration. Now, there is an initialization that is happening. So, the array now has a space of storing 5 floating point numbers. The first one is stored at the index position of 0, so I will scroll down so you can see it. So, meaning, this float data type can now contain up to 5 values. Meaning, it takes up 5 times more memory in your computer for you in order to store 5 more values. So for the weight array data type, it now takes up 5 memory spaces, which can be indexed as 0, 1, 2, 3, and 4. Now, you can now populate the array as follows. So he is populating the initialized variable. So, if we copy this, let's say, put it in here. It now means that each of the initialized memory states now contains 5 different values. So, for here, in weight array, memory section 0, he had inputted 85. Though, F is just a formalization of code, it can also be eliminated. It's fine if you don't have to put the F letter there. It's fine. So, here, he has inserted 85 for memory 0. Then, 72 for 1. Then, 68 for 2. Then, so on and so forth. It can also be declared and initialized at the same time. Same as how he did in this initialization and population. So, this whole process can be done in a single line. So, this is how it is done in a single line. You just have to declare it like this. Anyway, you can copy-paste the code if you want to try it in Android Studio. So, float, wait array, so on and so forth. We can remove the F if you wanted to, but it is fine. Now, this way, the data type is given, the array is indicated with the square brackets. So, float, wait array, then the name is given as wait array and the size is set based on the number of elements given between the brackets. So, I did not expound much on arrays as we will be learning it on the field, or rather, more directly. So, this is just a basic explanation of how an array works. So, another example of array. You can store the entire multiplication table using an array. So, as you notice, array, the weight array is a one-dimensional array, meaning it only goes at a straight line. You can make two-dimensional or even three-dimensional arrays if you wanted to. For example, we are going to create what we call a two-dimensional array. You'll just have to add another square bracket to that. So, let's name it multiplication table. So, for example, we are going to insert float in the 0, 0 position. What do you think would be in the 0, 0 position? Which is the most bottom left of our equation. Or rather, wait. It could be 1 times 1, right? So the value can be 1. Then, another 1. So, it should be 2. Do you understand my logic now? Well, I can give you explanation regarding arrays if you wanted to. Pero, just think of arrays as expansion of the actual memory that you are going to use for your programming needs. It doesn't have to be an array every time, but you will be dealing more and more of this as we go on with our lessons. So, now, we move on with operators. Operators make every variable function. For this variables, the data types, they cannot manipulate themselves. We need something to be able to change the value of these numbers. So, operators perform data manipulations on one or two input variables. Now, in the context of operators, we will call variables as operands. Because we will be dealing with math in this time. Don't worry, the math will be just as basic as it is. We can even call it math. We can call it arithmetic for it if you want to be comfortable with it. So, for example, in the expression 2 plus 3, the operands are 2 and 3. The plus sign there will be the operator. In terms of the number of operands, a distinction can be made among the unary operators. So, let's just define what this unary, binary, and ternary operators is. So, unary operators can function with a single operand alone. For example, that is where C is the operand and the plus plus, also called as the increment operator, is the operator. That's where C++ derives from its name. It's C plus more. So, in terms of number of operands, a distinction can be made among unary operators, which use one operand, binary operators, which is the most commonly what we encounter. For example, C plus D. That is a binary operator. Then, lastly, ternary operators, which function with 3 operands. In terms of operations performed, a distinction can be made among the following. So, another classification. There are 5 operators that we are going to be acquainted from. These are the arithmetic operators, assignment operators, bitwise operators, logical, and relational operators. So, let's start with the arithmetic operators. Arithmetic operators are something that we have already encountered with in our as early as we are starting to learn about numbers, right? Arithmetic. These are the 4 basic mathematical functions plus 1, which is modulo. So, it is addition, subtraction, multiplication, division, and modulo. I hope you acquaint yourselves with the operator signs. As you might have noticed, I didn't use the division sign that we usually use when we divide a number. Because in programming, we do not use that kind of sign. We will be using slash or backslash rather to perform a division operation. For multiplication, instead of a symbol that looks like letter X, we will be using asterisk. And for modulo, we will be using percent as the operator. So let's test the operators. See here, I have already created a basic calculator. It's not actually the one similar to what you have made, but this performs an operation depending on the value that you have inputted. So, I'll go to the line in which modulo is being computed. So, I hope you understand what modulo is. Modulo is a division remainder. So, I'll try to run the program from my phone. So, I think you are already acquainted with this operations, right? But we will just sample it. Let's say 10 or rather 7. They are using the same numbers, okay? So I will just use the same numbers. So it should be the same. The result should be the same. So 7 plus 3, that is addition. So the answer should be 10. Then 7 minus 3, it should be 4. 7 times 3, it should be 21. And 7 divided by 3 should be 2. If the integer data type is being used. But unfortunately, I have using a double, which means that it will count the decimal places. As you might have noticed, it has counted the decimal places. But this result should show up if integer data type is being used. Now, going back, 7 is the operand 1, operand 2 is 3. So, why do you think the result is 1? Any answers from the students? Why do you think the result is 1? I will be giving bonus points to those who can answer. Okay, Koji?
Can you hear me, sir?
Yes.
I think it's because 7 divided by 3 is the whole number it can make you convert that over 1. So the result is 1.
Okay, correct. Good job. So, again, the answer has come up because it is what we call the remainder of our division operation. Another example would be 23 divided by 3. What do you think could be the modulo? Another person from the crowd? Okay, from Gamutan, the answer is 2. And let's test it. Wait, how do we close this pop-up? And yes, correct. The answer is 2. So, I think you can get the function of modulo now, right? So, modulo is very useful when we are going to get the whole number equation or the whole number result of the remainder of such division operations. Usually kasi, when we are dealing with division, the remainder is usually shown in fractional form or what we call decimal points, right? So, this is useful for this this situation. For example, you are trying to pinpoint your exact age. The operation for that would be division, right? You are going to divide it to the years, to the days, to the months, down to if you know the hours. But it will result with decimal, or rather, it will result in decimal points. Very what do you call this? Fractional answer. So if you can pinpoint how many of those using the modulo, then you can create a precise program in how you can count how many days, even to hours. You will be using this in the future, so don't worry. So now let's move on to assignment operators. Assignment operators are those that we use to assign a value to a variable. So let's zoom in this. Let's get this line in which we used for the modulo. Let's try to put this here. So there are two operands and one resultant variable. The resultant variable is answer and two operand variables, operand 1 and operand 2. The operators there are the modulo sign and the assignment operator. This is, you will be getting confused with this because we are oriented that this sign is what we call as equals. We have been ingrained in our mind that we call this equals, right? Meaning that we, whatever the value is, it should be the value of that. So, we need to unbox our thinking regarding this because we will be getting confused if we stick with the mentality that this sign is what we call equals. So, instead of using the word equals for this, we will be using the term is assigned the value of instead of equals. Okay? We will be using this term instead. So, for example, let's translate this into words. So, integer x is assigned the value of 5. That's how we read this, ha. Or double y is assigned the value of 2.5 plus 3.6. There is a difference between equals and assigned value. This usually happens when we think that, oh, this is equals. This will be actually happening, especially if we are going to deal with relational and conditional operators later on. Because you will get confused, sir, why didn't the equals sign work? So, we will get to there. So, not only there is this kind of symbol which we call equals to use as the operator, because this operator is usually can be it is not a unary operator. This is a binary operator because it requires you to have two or more operands in there, right? Operand 1 and the value. It could be operand 1, then operand 2, and operand 3. So, it can have two or more operands. So, we cannot call this a unary operator. But, these other signs are unary operators. So, how do we use them? For example, you are tasked in counting how many entrants a nightclub has. So, for example, you will start with a value of 0 because you don't have a guest. So, let's say int guests is equals to 0. So, if you're going to count each entrant in our club, then the formula would be guests plus equals 1, which is very similar to the formula guests is equals, or rather is assigned the value of guests plus 1. So, sir, how does this formula work? Again, the value of guest is 0. We assigned it the value of 0. So, store it in your brain for a bit. Guest has a value of 0. So, this is what happens. So, again, 0, a guest is 0, right? So, before we get the value of the guess, the final value, the value of guess is 0. So it would become 0 plus 1. Now, it will become 1. So now, the value of guess is 1. So if we add another line, the value will become 2. Or rather, but so who can answer what the current value of guests is this time? What is the current value of guests in this final equation? Okay? Uh, Tamarad, your answer is correct. So the value of the guest this time should be 4. Because the formula should be guests is assign the value of original value of guest plus 2. In which the original value of guest now is currently 2. This will be the quiz that you will be getting from this lesson, okay? So you need to orient yourselves in how the formula works. So, basically, assignment operators other than the one we call equals is just a shorthand or a shortcut on how we are going to manipulate the values unary style without any other operators, okay? Logical operators. We are already acquainted with this last semester. After all, we have been using truth tables since last semester. I think you have already did logic or truth tables regarding this. So, this is just a short rundown of what a logical operator is. Logical operator is very useful when used with the data type Boolean. Again, Boolean can only have two states of value. It can be either true or false. Or false. You can only store either of those as value. So, in logical operator, there it illustrates the logical operators can be used. So, 3 is greater than 2, which is actually true, right? So, 2 is less than 1, which is false. So, these are the operators. You need to acquaint yourselves again with these operators. Now, so, this is what we call the conditional AND operators. It is denoted by 2 ampersand, which is in your number 7, ampersand symbols, and use it along with the what do you call this, operands. For example, x, y, x and y. So let's have a little refresher of your knowledge in truth tables, okay? So let's say x is true. Let's just assume that both are Boolean values, and again, read here, just look at this, then try to answer. I will be giving points to those who manage to correctly answer today. The first one that I will accept. So, just answer to me if whether it is true or false. So, let's say, let's hide this for a bit. I think this is not a challenge for you anymore. So let's add another operand. Okay. Maybe there will only be 2 students qualified for this. Let's see. What do you think is the final value? I hope you sharpened your skills in truth tables.
Is it true, sir?
Sige, explain your answer. Why do you think it's true?
I think it's because the parentheses here, so X and two symbols, and then Y is false, and then I use unary as the final one. So it says if true if the operand is false, and since X and X to the Y is false, then it's true.
Okay. Okay, let's
Okay, okay.
no, don't worry. We will be just expounding upon the answer of Koji, okay? So, this is how it's done. So, again, true, X is true. And Y is false. So, true and false, what do you think is the result? You can just type it in chat. The result would be false, right? So, the answer will become false. The function of not operator, it reverses whatever the value is. If it is false, it will become true. If it is true, it will become false. So, Koji is correct in this answer, in his answer. So, simple enough, right? This is how we are going to be dealing with logical operators. Logical operators is important, especially if we are going to be dealing with decision making. For example, remember what we did in our first activity in which you are going to create a flowchart? If we translate it in program, this would be basically like this. That is the use of logical operators. But there's another similar one that uses also the same type. It also uses true or false for this matter. So, let's deal with this bitwise operators is, I don't think we will be discussing bitwise operators. So, there are two actually logical operators in here. It is not just logical operators that use this. There is also, you call this, the bitwise one. The bitwise uses just a single of each character. So don't worry about bitwise operators. We will not be using bitwise operators because I think it will be a bit hard for you because it deals with bit by bit operations, which is zeros and ones. So lots of zeros and ones. It is basically binary. So to take off that difficulty from you, we will not be dealing with bitwise operators. So I guess this ends our discussion for operators. Now, we will be just touching on how we are going to create our calculator. So I would like you to open your calculator designs. I would like to open your calculator. So for me, I will be opening the one that you have already created. I have also created one for mine. So this is the calculator that I have created. So for ease of use, I would like you to change the IDs of each buttons according to what the data is. So let me zoom this in. So for example, the multiplication sign should be named as multiplication button or whatever you name it is. For me, I name it button mode. So just an orientation of the naming conventions. that are being used. Kasi baka you are getting confused on how we name our objects or our things. So, in programming in Java, we are dealing with three naming conventions. There is the upper camel case, there is the lower camel case, and there is a flat case. I'm sure you're already oriented with what do you call this? Uppercase and lowercase, right? So, upper camel case. Upper camel case is the case convention that we are going to use when naming classes. If we go here in our main activity.java, it starts with a capital letter, right? Then each word starts with another capital. So that is what we call upper camel case. So lower camel cases are being used for variable names and objects. For example, we are going to declare int or int my age. So you start with small letter for the first word, then capital letter for another word. So lastly, the flat case. Flat case is used when naming packages or Java packages. So if you notice this when you are going to create a new project, this is the package name. As you might have seen, all are in lowercase. So that is a flat case. Flat case means everything is in lowercase. I hope that is clear to you. So now, I want you to rename all the buttons according to their function. For example, this is the equals button. Let me zoom this in. There. Okay, let's see this in blueprint. Okay. So this is the equals button, right? So I'm just going to name this button equal, btn equal. Then refactor. Simple as that. Plus symbol, button, add. Then button subtract, or I'll just name it sub. Then button divide. Each button should be named according to their So for this, let's just name this button 7. Numbers are valid as long as they are not used first. Okay? Numbers in the names of variables or objects is valid as long as it is not used first. So btn 8, btn 9, btn 4, so let's make this a bit faster, no? Because I will have a class later. So why can't I modify 6 or well, whatever? I'll just modify it via code. So you can click the code as a split option, then click the button. Then let's just name it what do we call this? So this is it. Let's just name it btn. Why can't I type? Did my keyboard die? Well, I want you to rename this. Then let's go. After renaming everything, you will notice that main activity. Why is it not working? Wait, I think I bugged my keyboard. Let me close this and open it again. Let me reopen the project because I think it's bugged. So any changes should be pushed, because this is already in GitHub, right? So you need to push any changes you have to the GitHub server. So how do you do this? Just click the green check mark if you have already committed this in GitHub. This will not show up if the project is not yet uploaded in GitHub. Because we are already editing a project that's already in GitHub, this should show up. So just click the check button, which is commit. Then let's name this remove. Let me just then rename or refactor button names. Okay. Then commit and push. Then commit and push. Then it should show up at the GitHub website. So 3 files committed. So we have already done the commits in our server. So let's just continue our edits. Where did we left off? So button 9, button 4, button 5, button 6. So this should be button 6. So let's just rename this button 6. Oh, I forgot. You need to refactor pala. So again, go to the attributes. We need to refactor. You don't have to do this by code. So just do this using refactor because it will destroy your layout when you're going to rename it. So just refactor. Via code, you can do this by what's the button is this? Let me check. Button 1. So we can do this in code. If we go click here, then it will highlight what you are going to edit. So it's the plus minus symbol, which I don't think we will be using. So where's that button? So here it is. So let's rename this button change sign or something. Again, just refactor it. Highlight the ID. Highlight the ID, then click refactor. Then rename. Then let's name it button change symbol. Then refactor. So now it works. So again, let's do this for number 3. This should be number 2. Where is number 2? Let's add the text number 2. For today, if we are not we don't have sufficient time, we will be doing this again tomorrow. So again, rename all your buttons according to their function, so that it will be easier for you to identify later. So button 3, button 0, then button decimal point. So now that I have refactored everything, maybe let's refactor this text view and name it text display, because we will be displaying our values there. So now let's go to the main activity.java. So you will see this code in main activity.java, right? There is a void function. This is a void method. This is a method. So This is a void method. We will be discussing about methods tomorrow. We have already discussed objects, everything about objects. So we will be discussing void methods today or tomorrow. So I would like you to paste this code, or rather, just go, di ko lang alam kung nandito na ba yan. Let me check. So, I would like you to rename your code, ha. Kung makahabol kayo, then go ahead. I will be showing you the code. So, we will be adding the buttons here. All of the buttons. So, let's type button. Then, we will be declaring the button. Button is an object that functions like a variable. So button, we will name it btn1, btn2, btn3, btn4. Let's start with btn0 because we have a 0 button. btn0, btn1, btn2, btn3, btn5, btn6, btn7, btn8, btn9, and the btn symbols, the other btn symbol, btn add, btn sub, btn div, btn mult, btn, what other, modulo. So let's stop by there. I think this is getting way too long. So now that we have declared most core functions of the calculator as a button, we are going to ID them according to their names in activity XML. So notice here in the code there is a name, right? So we are going to recall everything here. So for example, button, we are going to pair up the code with the XML file. So button 0 is equals to find view by ID, then r dot ID, then what's the name of the button? Button 0. So that's it. Okay. I'll paste this code here para lang makita nyo. Ayan. Ayan na, sinend ko yung code sa chat. So let's just copy paste it here. Then slowly change the button. Button 1, button 2. Oh. 2, 3, 4, 5, 6, 7, 8, 9. Then change it here as well. We'll just highlight this instead. 4, 5. So we will end our class with this. So I hope you do this also for the other symbols, okay? All the buttons should be mapped. We are mapping the buttons to the code so that we can manipulate the buttons via code. So I want you to map every button here. Lastly, we are going to add an on-click listener to this. So we are going to set an on-click listener for each button. Whatever. We will be adding the on-click listeners tomorrow. So we will end with this. So make sure every button is complete before adding it to commit. I will be committing this because there are lots of added buttons in code. Then commit and push. then commit and push, push. Then that's it. If you have any questions, guys, you may give me a message. I will be uploading this video on YouTube, don't worry. So, that concludes our class for today. Thank you so much for your participation. I hope you have a nice day ahead. We will be continuing this tomorrow. Goodbye. Thank you.
Goodbye and thank you, sir.